points in the board exam. Okay, so please do take into consideration these blood group systems. All right, so we're going to start first with the general characteristics of the other blood group systems. So blood group systems sometimes are often related to the other blood group systems are that we're going to talk about are oftentimes related to the blood group ABO. Okay, so the blood group ABO. What do I mean by that? You'll see why later. But you just need to remember that there are three blood group systems that are associated with the ABO blood group system. The Lewis, the I blood group system. Please include the small I here. The P1PK blood group system. Okay. Previously, this was just P1. This was just P blood group system, but now they changed it to P1PK. Okay, cool. All right, let's move on to another characteristic. Blood group systems are enhanced by enzyme proteolysis. What blood group systems are enhanced by enzyme proteolysis? You need to talk about again those three blood group systems plus the addition of the RH and the ABO blood group systems. I'm going to give you guys an example of what I mean by enzymatic proteolysis. So, take for example, this is your RBC surface. Now, I'm not talking specifically of any blood group systems right now. What I'm talking about is the blood cell surface in general. What it looks like is this round thing that is in front of you guys, or this half circle that is in front of you. This is the intracellular membrane, and that is the external portion of the RBC. Okay. Now, the funny thing about the RBC blood groups is that there's so many of them. And like what you might expect, some of them can be close enough to each other, or sometimes it's too large. Okay, say for example, this is one. This is an example of a blood group system. Okay, and that's another blood group system. That's one blood group system. Okay, this is just a uh, rough illustration of an extremely rough illustration of one of the blood group systems. Okay, and these things can actually block the smaller blood group systems that you might have here. For example, small chain blood group systems are here. It's starting to look like a it's starting to look like the outer portion of a virus. But when you look at it in an electron microscope, when you look at an RBC in an electron microscope, the surface of the RBC is as such. Now, immunoglobulins, as I mentioned last week before, are capable um, of binding to the specific antibodies, to the antigens that we have, the antithetical antigens. So, for example, you have an immunoglobulin that is here on the top, and the target of that one is the yellow ones down there at the bottom. You won't be able to reach it, correct? So the target of that one is specific, or the hypervariable region is specific for these things over here, these guys over here at the bottom. Because of the tall ones on the top, because of the tall ones or the large molecules, the immunoglobulin is not going to be able to reach it, or some of it may be able to reach it, but there might be a weak reaction. So one thing that we need to do is we use enzymes. And what an enzyme does is it enhances the reaction of the ones at the bottom by cleaving the larger molecules of other blood groups or other ones here. So it will erase some parts of the other blood groups in order for the in order for the immunoglobulins to reach it. Okay? So please do take into consideration these six blood groups that are enhanced by by proteolytic enzymes rather, not chemicals. Okay? So what are the enzymes that we can use for the enhancement of RBC RBC blood that enhances the reaction of RBC blood groups. Can somebody give me one? The one that came from papayas, the one that came from pineapples, the one that came from pineapple leaves. Anybody? Can you guys still remember the last week's lecture about enzymatic enhancement or proteolytic enzyme enhancement? We have what? Anybody? Oh, they forgot now. They forgot. Let's try calling somebody. Um, I haven't heard your voice for a very long time. Where is April Roselo? Rosero, sorry. April, give me an enzyme that can enhance the reaction of other blood groups and destroy some blood group systems. Anybody? Nobody? Gina. Gina. Okay, you raised your hand, Gina. Okay. Okay, that's good. So you added an extra one, but in the board exams that they're going to ask you papain, bromelain, and phycine. All right. Thank you, Gina. All right. Now we're going. Hello. All right. So I'm back. Yeah, I'm back. Now we're going to talk about the immunoglobulins. Sorry, the enzymes rather. Wait. Nasaan na yung ano ko? Ba't nawala ako? Pero may slideshow sa harap nyo. Ba't nawala sa akin? Meron dyan sa inyo? May slideshow dyan? Sa akin nawala. Kasi dito sa ano ko meron eh. Kabilang monitor meron. Kakagulo si kabilang monitor. Ay, okay. Okay na. Please double check kung na-move na if the slideshow is moving. Nag-move siya. All right, thank you. All right, so what blood groups are decreased by the activity of proteolytic enzymes? The Duffy, the MNSS, and Lutheran. They're going to ask you about this in the board exam. So please remember these six and these three that are decreased by proteolysis. Okay? Don't forget papain, bromelain, and phycin. Okay? Papain comes from papaya, bromelain and phycin comes from pineapples. All right? Now, let's talk about the Lewis blood group system. The Lewis blood group system is related to what blood groups system? Again, I mentioned it before. It is related, intimately related to the ABO blood group system. And note that also P1PK and the I blood group systems are related to ABO. Just a reminder. Okay. Now, the genes that are responsible for the Lewis blood group of the patient is the two genes that are very important. The FUT3 gene, okay, and the FUT2 gene. FUT2 gene, you might be familiar with this one because I mentioned it last week. It's actually the ABO secretor gene, okay, all right, the ABO secretor gene. Now, it might be phenotype as S, E, or the null one or the non-secretor haplotype, which is this one. Small ESE and the big SE. Lewis antigens, on the other hand, will produce LEA, small one, LEB, but we'll talk about that one later. All right, we'll talk about that one later. What does FUT3 mean? It's basically like a fucosyl transferase. What it does is it transfers the fucosyl molecules in the base molecule. Okay? So what are we talking about? The base molecule. What molecule are we talking about? So the base molecule is basically your GalNAc. Okay? Your GalNAc. The base molecule is type 1. We have two types. We have type 1 and type 2 base molecule. What is it? I'm going to use a red pen. So this is the biochemical general biochemical structure. So for type 1, it is a molecule that has glucose and acetyl glucose plus galactose. Sorry, ang pangit ng drawing. Ang pangit. Ayoko. Gusto ko yung maganda para sa inyo, class. I want it to look as artistically created as possible. Alright? Okay? So, mukha na siyang hexagon, no? Basta mukha siyang piatos, guys. Okay? Just remember there's six sides to this particular sugar. Because this one is, the name for this one is glucose and NAC. Galnac. So that's galnac. Okay? Glucose and acetyl. And it has, sorry, erase that one. It has a beta 1,3 linkage. If it's type 1, it has a beta 1,3 linkage of galactose here. So how do I know it's a beta 1 linkage of galactose? Because you have to count 1, 2, 3. All right? So there's six sides. 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay? This one is another side. This one is another side. This one. So this one has galactose here. Now, for type 2 have the same structure. May piatos din. Hindi siya mukhang six-sided. Ang hirap mag-drawing. Namimiss ko tuloy yung mag-chalk. Gumamit ng chalk. Nakakamiss. Alright? So you have to have 1, 2, 3. 1, 2, 3. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. So type 1 has beta 3 linkage of the galactose. Type 2 has beta 1, 4 linkage. Now, how do I know it's 1, 4? 1, 2, 3, 4. Okay? Beta 1, 4 linkage of galactose. Okay? So that's the one that is used by Lewis antigens is type 1. Okay? It's the type 1 oligosaccharide. That's the answer to this question. What is the base molecule for the Lewis antigens? This is the type 1 molecule. All right. Now, enzymatic products of the enzymatic products of SE gene converts the base molecule into molecule for the Lewis antigen as an H antigen. Really, sir? Bakit? Akala ko H antigen gives the person type O blood group. No. In this case, H antigen is useful for the Lewis antigen. Why? Because it will attach a fucose molecule. Remember, it's the 1,3. It will attach a fucose molecule here on the 1,4 location. There will be a fucose molecule here, and this one will be your galactose. This one will be your galactose. Okay? That's what happens with the secretor gene. All right? That's for SE. This is for SE. If you inherit one of the haplotypes, capital SE. Okay, capital S, small letter E. All right? Now, if you don't have that one, you won't have a fucose attached to the 1,4 linkage. That you won't have a 1,4 linkage of the fucose. This one is fucose. This one is galactose. Please be mindful of that one. Now, this one by itself is known as the H antigen. Really, sir? Yes, this is the H1 antigen. It may not look like it in some drawings, but yeah, it does. Now, the FUT3 gene has an allelic designation on the as an LE, allelic designation. That's the allele of this one. Okay, back to the genetics na naman tayo. An allele is the portion of the an allele is a portion of the chromosome that may vary depending on the individual. So for example, what are the alleles of a type O individual? OO lang kasi recessive gene siya. What are the possible alleles of an A individual? So if they ask you a question in the board exam, somebody give me an answer. Joko Lopez. Give me the alleles of a person who is a type A individual, the possible alleles. Kasi nagsagot si Joko Lopez ng yes po. So I know he's there. He or she is there. I don't know. Joko, are you still there? Joko. Hello. Joko. Alright, wala siya. Who can answer this question? Somebody in the chat. I'm gonna come back to this one because we have a lot of topics to cover. I can't wait for you guys to answer. What are the possible alleles of a patient who is type AB na lang? Type B naman. Kasi sinagot ninyo tama eh. Tama mga sinagot ninyo eh. So type B naman tayo. Okay? So in this case, we only have two types of allele. We have the active form and the inactive or the amorph designation. The amorph means that this one is not going to produce any enzyme product, which means there's nothing. It's basically just the absence of the LE. So you have one, the active form, and the amorph form is this one, small letter L. Okay? So this is the allelic designation. It will produce the FUT3. FUT3 is what? Fucosyl transferase 3. Okay, FUT3, hence the term FUT3. That is the L. The LE1 is the capital letter is the active allele. All right. Okay, so a lot of people answered correctly. Thank you so much. Thank you, thank you. All right. Now, if I ask you the question, what are what are the possible alleles of an of an RH negative individual? Oh, yan tayo mahihirapan. Diyan tayo mahihirapan. Same pa rin, you can answer in the chat because apparently you guys don't want to unmute. Pero feeling ko talaga galit kayo sa akin kasi hindi na kayo nagsasalita unlike last week. Nag-aalala tuloy ako. Alright? Okay. So guys, kahit nagalit kayo sa akin, we have to continue. I have to do my job. Alright? Where would the fucosyltransferase 3 enzyme attach the glucose molecule? This is not glucose molecule, sorry. I don't know what I was thinking, but let me edit it out for you. I don't know what I was thinking. It was supposed to be fucose molecule, huh? Fucose. So please answer, huh? Please answer this one in the chat. I will come back to you guys later. All right? All right. So where would the fucosyl transferase attach a fucose molecule in the type 1 oligopolysaccharide? So fucosyl 3. Fucosyl 3 will attach it to the hindi pala bumalik. Sorry naman. Sorry naman, sorry. Okay. Can you guys see it now? All right. Thank you. Okay, thank you, thank you. All right, so where would it attach it? Fucosol 3. We're talking about Fucosol 3. It at the 1,4 linkage. All right, what do I say when I mean 1,4 linkage? Look at your previous discussion. Look at our previous discussion. One, two, three, four, five, six. You have one, two, three, one, two, three. We have a galactose here. For foot 3, it will attach it here. One, two, three, four. That will be another fucose molecule here. So LEA. Okay? Now, if a person has foot 3 and foot FUT and as the end, what is the end product? H antigen plus LEB. What's LEB, sir? Bakit naman may LEB? Okay? What will be the product if a person inherits both of these genes? They will have an H antigen and LEB. So please tell me what is an LEB. So sir, ano naman yung LEB na yan? So it's basically the same product. You'll have your galactose here. And then what will happen is that you have an H antigen already because you have the secretor gene here. And then what it does is it's going to attach another fucose molecule here. Okay? So you have three structures. Now that's the LEB structure. Now, what type of biochemical relationship does these two have? Does the LE and the SE enzymes have? They have a competitive relationship with each other. SE enzymes have a stronger reactivity to type 1 chains than the LE enzymes. Okay? Both of them will compete for type 1 chains. So therefore, for example, in your RBCs, you will have what? You will have LEA. You will have LEA in some parts of your RBCs. Let's just say, for example, you have LEA here, and then most of them will have what? H antigens. Now, if it become now the interesting part about this is that if you read it in your notes or if you read it in the books, once a molecule is changed to LEA, okay, once the molecule is changed to LEA, it will lock itself and it will no longer react with the SE enzymes. But remember, because SE enzymes has a stronger reactivity type 1 chains, they will be more likely to have a lot of H antigens. And when there's a lot of H antigens, the next step for this molecule will be to attach another galactose molecule and they will form LEB. Sir, parang ang gulo. Bakit parang naguluhan ako, sir? Akala ko, sir, pag nag-blood type tayo, iisa lang ang blood type mo. No, no. In this case, in the Lewis blood group system, once an H antigen is formed, automatically, if you have the allele LEA, or if you have the LEA allele, you will automatically have LEB and LEA. Okay? It just so happens it goes to an extra step to form LEB. Paano yun, sir? Okay? Bibigyan kita ng example ha. This is the this is how you would this is how I will explain it to you guys. All right? So let's start first at the very beginning para maintindihan nating lahat. Okay? Para maintindihan nating lahat. Let's start first at the beginning. You form your H antigen. Bilog na lang kasi medyo mahirap na. So H antigen siya. So yun yung may galactose na nakasabit, di ba? Clear? Clear ba, Earl? All right. Because you have what gene? You have an SE gene. Okay? Now on this side, you have the Le. You are a patient. You are a person who has both Le and Se genes. Okay. Now in this side, you're producing LEA. How is LEA being produced? You need to have another fucose molecule on the 1,4 designation. This one is LEA. Now, going back to this one, the H antigen promotes the action of the Le enzyme, which is what? Which is the fucosyl transferase. Therefore, it will attach another galactose molecule. It will attach another galactose molecule forming LEA. Now, because this one is stronger, there will be more LEA molecules in the LEB molecules in the RBC if you have this phenotype or if you have both of them in your genotype. So I will designate this as color yellow so you guys will know. Okay, okay, okay. So you will have more. You will basically have, uh, in this particular illustration, we're going to have more LEAs. Okay, you're clear with that one, right? You need to have the base molecule H in order for you to attach the Le substance or the LEB substance to form the LEB antigen. Okay? So even though you have LEA, because you have SE antigen, it will promote the production of the H antigen. That's the time this same enzyme will attach this one. Okay? So parang mangyayari is parang maboboard siya kasi mas malakas kasi si H. Sige, bigyan ko na lang siya ng time para umattach, then saka ako kakabit. Ganon. Okay? So what do you think will be the reaction of this type of patient? So for example, you've inherited LEA, okay? LE and SE. What do you think will be your Lewis blood type? What do you think your Lewis blood type will be if you inherited the same conditions? What do you think your Lewis blood type will be? Um, will it be one of the following? LE, A, negative, B, positive? Will it be LE, A, positive, B, positive? Or will it be LE, A, positive, B, negative? Now we're talking about your phenotype. Nagets nyo from our discussion here? Okay? So parang maboboard si LE antigen kasi wala siyang ginagawa, pinangungunahan siya ni SE. Gagawa na lang siya after nito mag-attach ng fucose. So gagawa siya ng LEB substance na. This one, nauna siyang kumabit, pero since malakas siya, onti lang yung nagawa niya. Pero locked in na siya as like that. Gets nyo? Yung difference? Now, I have some choices for you before we answer this table. Uy! Uy, 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 wag muna, wag muna. Sorry, nadulas. Alright, so, because of that, knowing the competitiveness, knowing the structures that you're going to have, and knowing the knowledge of expressions, please tell me the blood group of your patient if you inherit LE and capital SE. Anybody? You can guess, don't worry. Let's start with Ella Villamayor. What's Renalyn Amparo said Renalyn Amparo said LA negative, B positive. Okay. Let's go with another person. I want to see everybody's answer. You have choices in front of you, don't worry. If If you answered incorrectly, don't worry. This is not going to be graded. Don't worry. LEA negative, LEA negative, B positive. All right. All right. Who else? What about you, Jan Ilagan? What is your answer? Oh, di ba talagang hinahanap ko talaga lagi si Jan Ilagan. Jan Ilagan, what is your answer? Ay, ang tagal ni Jan Ilagan magsalita ako ngayon. Ayan. LEA negative, B positive po. Oh, it's very, very respectful pa rin siya. Like, kahit na binubuli ko siya, he is still saying po. I love it. Thank you, John Ilagan. All right, Jovel Hatosis said, what? LA negative, B positive. All right, so everybody answered almost unanimously except for Jovel Hatosis. Let's see the answer. The answer is number one, choice number one. Everybody answered correctly. Why? Why, sir? Why mangyari yon, sir? Remember, sir, remember, guys, that you have a lot of this one. You have a lot of LEB substance. Okay? You have a lot of LEB substance. The reaction is stronger, and therefore there will be uh, much more of that one. So the most commonly expressed antigens in the surface of your RBCs will be LEB. So therefore, your patient will be LEB positive, LEA negative because it will not be able to react as strong as the LEB substance. Okay? Now, will I see it in my serum? Of course. Will I see it in my other ones? All right. So let's try to answer this one. For example, this is our patient. The Lewis and secretor status of the patient is that one. We already answered that one, I think. So I don't think we have any problems with that one. If the Lewis phenotype will be LEA negative, B positive. Why? Because the B is stronger, has more binding sites for our reagent sera, right? And yes, there's a reagent sera. Now, for this one, what do you think will be the what do you think will be the Lewis phenotype? What do you think will be the Lewis phenotype of this patient? Can anybody answer? Same choices. All right. What is the Lewis phenotype of a person who is, I will type it in the chat, LE, no secretor gene. So you don't inherit any secretor gene, so you'll be like this. Well, the correct answer is, so you don't have a secretor gene, and therefore you will just be basing the structure on the base molecule. So you will be only be attaching fucose. Therefore, yes, everybody answered correctly. You will be A positive. Let's double check. Yes, double check. All right. So for this one, what will be our what will be our Lewis phenotype? Our Lewis phenotype. So we will have a lot of H antigens. For the third one, Lewis. Ay, mali yung ano mo ha, nomenclature mo. Ella Villamayor, use LE. That is for another blood group system ha. Ella ha, please LE. Use LE. Okay, in the board exam they use LE ha. Okay, thank you LE. Thank you Ella Villamayor. So for this one, what will be your patient's phenotype? Lewis phenotype. All right, Gina answered correctly. Why? Because you need to have a secretor gene to attach you only have a secretor gene, and therefore you're only gonna be type O. Gets nyo? You're only gonna be a type O person. Okay? What about this one? You have nothing. So, eh, LE negative, LE negative ka din. So same silang dalawa. Okay? Pinagkaiba mo lang dito, may blood type ka. Type O ka. Gets? Or do you guys need me to repeat? Nagets ba? Nagets mo ano? Nagets mo dyan, Mediana? All right. Thank you. So I don't need to repeat na ha. All right. What about John Median, John Ilagan? John Ilagan, did you understand? All right. Pag tinanong kita mamaya ha, John Ilagan, pag tinanong kita mamaya, ibibigay ko si Creator status at saka ang Lewis phenotype ay Lewis genotype ng pasyente. Kailangan masagot mo ako ha. Hopefully, ayoko ng hopefully. Gusto ko na, sure, sir. Sure, why not? Ganon. Ganon. All right. All right. What about Earl? Did you get it correct? Did you get it? Or did you understood it? Okay. What about Jovelhitosis? I like her name really. I really like her last name. I really like her name. Okay. Okay, so now let's move on to the Lewis antigen. What is the biochemical structure of Lewis antigens in the plasma? So in the plasma, it is the Lewis, it is going to be found as glycolipids. It's going to be attached to glycolipids. In the secretions, it will be glycoproteins. Okay? To be attached to carrier proteins. This one will be in carrier lipids. Okay? Cool? Okay? So no need to elaborate on that one further. That's pretty straightforward. All you need to do is remember those things. Now, how do Lewis antigens behave in the surface of RBCs? Actually, they are constantly being transferred in and out of the base molecule of the RBC membrane. They're not actually as strong as the other blood group systems. They can actually interchange. They can actually go into different things, and you will know this. You will appreciate this discussion later. So I'm going to give you guys a bit of a lesson on lesson on the dynamics of enzymatic reactions. Not all of the fucose will stick in there together. Not all of the fucose will stick there all the time. Now, for example, your patient is LESE. Okay, so they're going to constantly going to produce H antigens in the RBC surface, right? Correct. So this is going to be an H antigen, right? And around the surface of the RBC, you will keep attaching LEB. Why? Because this is the precursor molecule for the LEB blood type, okay? Or the LEB phenotype. You need to have H antigen to form LEB or Lewis B. All right? Now, sometimes you have LEA, but that's just a small fraction of the but that's just a small fraction of the amount of LEB substance. It can go either through the secretions or through the plasma. And if it's attached to the plasma, what did I say? It will attach to glycoproteins, correct? Glycolipids, sorry. Glycolipids. Sorry. Glycolipids. Okay? So it will be attached to glycolipids. If it goes to the secretion, it will attach to the glycoproteins. Okay? Imagine this is RBC. This is what again? Plasma. This is now your secretions. Okay? Now, this happens constantly. LEB gets detached, it will attach here, then it will come back again here in the RBC membrane once it just feels like it. So it happens at a very constant rate. You don't actually in if you look at it on a perspective of in real time perspective, right now you are having right now you are constantly having LEB. You're having this type of blood group or Lewis blood group or Lewis phenotype and this Lewis phenotype at a constant rate. Okay? You're interchanging in between this one constantly. Okay? Each red cell in in your body is interchanging with that one because these are related to secretory antigens or to the secretory blood type. The fucose inside will not really the fucose in the cells will not stick there forever, unlike your other blood groups. Okay? Unlike the other blood groups, this one moves in and out. That's why it is important to discuss the Lewis antigen because they will ask you in the board exam which of the following antigens are constantly being moved about in the secretions and in the plasma. And you have to remember that the Lewis antigen is the only blood group system that is capable of constantly being moved in and out of the secretion and in the plasma and in the RBC membranes. Understood? So in real time, I will repeat, in real time, your RBCs are constantly changing the blood types. Okay? They're constantly changing their blood type. So you will hear you will hear they will sometimes rephrase the question, blood groups, which of the following blood groups are going to be present and absent, are constantly going to change in the human body. Oh, gaganunin ka lang nila niyan. Etos-etosin lang kayo niyan, guys. So please be mindful of this one. Now, aside from that one, the Lewis blood group system undergoes what you call the transitional phase. So, what do I mean by transitional phase? You are a baby or a neonate growing up into that one and into that one. Then you finally become an adult. Okay? For example, what do you think is your Lewis blood group when you are born? When you're a newborn, what is your Lewis blood group when you are born? When you are a newborn? Anybody? Choices are the following: LEA neg, B neg, A neg, B neg, LEA pass, B pass, LAB pass, LAB, and then LEA neg, B pass. What's your Lewis phenotype when you're a newborn? Those are the choices in your ano. All right, thank you, John Mendiana. That is the correct answer. All right, as you grow older, your Lewis phenotype will be what? You're still a child, but you're not a full-grown adult. What is your same choices, John Mendiana? What do you think will be your Lewis phenotype? Transitory phase. Unfortunately, you are incorrect. The next one would be LEA pass B pass. Why, sir? Ang kulit, ang gulo-gulo, sir. Bakit ganon? Wait ha, let me explain to you why. As you grow older, you're starting to produce LE substance and secretory substances. Correct? But in this, hello? Alright, so sorry. Disconnect yung audio ko. Alright? So, but they are at an equal rate, or LE is greater than secretory. Okay? So therefore, the expression is almost the same. Okay? But as you grow older, you will have your final phenotype. That will be the LF na lang ang tawag natin sa kanya. That will be the final Lewis phenotype. And that will depend on you. Alright? So newborns, you will transition to this one and this one. Okay? Okay, so adult Lewis phenotypes are going to be seen at the age of 6 years old. That will be your final Lewis phenotype, 6 years old. Okay? Now, let's talk about the Lewis antibodies. Lewis antibodies are not really interesting because they are of the IgM molecules. All right, they are of the IgM class. And how does one acquire their Lewis antibodies? Are they naturally occurring or do you need exposure? Naturally occurring or requires prior exposure? Anybody in the class? Type in the chat. Naturally occurring, all right. Friendiza Ontog answered naturally occurring. Okay. What about the other people? Other people? Exposure according to April. All right. Next, who else? John Mediana said naturally occurring for Gina Evangelista. All right. Renlin said naturally occurring. All right. All right. Earl said naturally occurring. Okay. Angela Felipe said naturally occurring. Okay. That's the last one, I think. Anybody else wants to try their hand at answering the question? It is actually naturally occurring. Why? As I mentioned before, they are related to the ABO blood group system. And the ABO blood group system are always going to be naturally occurring. Okay? Naturally occurring. Why though, sir? Because these are substances that are normally found in the antithetical portion of these antithetical, or rather antigens, have environmental factors in which the individual who does not have the antigen present will produce the antibodies. And it's not going to be just it's not just going to require prior exposure. Okay, so please be mindful of that one. All right, now let's talk about the Lewis phenotypes. Lewis antibodies are normally seen in what? It's actually going, sorry, can you guys hear me? Sorry. Hello, can you guys hear me? Okay na. Hello, ayan. So it's going to be seen in sa tingin nyo, which one of the phenotypes that we mentioned will produce Lewis antibodies? Same options. LEA neg, B pass, LEA pass, B pass, LEA neg, B pass, ay, LEA neg 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 neg, or the opposite of this one. LEA pass, B neg. What do you think? Which of the following phenotypes will produce antibodies? Anybody? Remember, antibodies are produced of in the absence of the antigen. So antithetically, is there an antithetic is the antithetical principle applicable in the Lewis antibodies? All right, a lot of people answered correctly. There was a couple of people who answered incorrectly. Earl Palmero said positive B. It's actually anti neg neg, anti Lewis
anti-Lewis antibodies will be produced in these patients. Okay, what are the types of antibodies that we have? Anti-LEA, okay, and anti-LEB. Okay, cool. So those are the two types that we're going to have. Now let's talk about the two types since we're talking about them right now. Now the anti-Lewis A is just as it is, but the complicated one is the Lewis B variants. Okay, so sir, parang COVID lang may variants. Yes, there's variants. They are typically seen as in again negative phenotypes, and patients who are we're going to answer this question first before we go to the anti-LEB antibodies. Patients who are anti-LEA negative, B positive will get anti-LEA or anti-LEA. True or false? True or false? You have choices. Guys, answer. Look at the genetics. Look at the phenotypes rather. Do you think this patient will develop anti-LEA? True or false? True, true, true. A lot of people answered true. Okay. False. There's only one person who answered false. Yes, that person is correct. John Mediana answered correctly. What? Sir, akala ko ba ano? Remember my discussion earlier? You have anti-LEA, but there's only a weak expression of it. Okay? You still have anti-LEA, and your predominant chain in this case is going to be anti-LEB. Why? Because it's just there. Okay? It's just there. Don't really um example ko kasi kanina is naboard lang si FUT3 enzyme. Okay? Naboard lang si FUT3 enzyme, kinabit niya sa may H antigen. So this one lock and loaded na siya. Hindi na siya maaalis. This one constantly goes in and out of the secretions. But this is always present regardless of your regardless of your status. The fact that you've inherited an LE antigen means that you have both of them. Okay? So the correct answer is false. There's just a stronger expression of the HSE antigens or the secretor antigens, which is synonymous to H antigen. And this one, once there's a fucose attached to it, that is known as LEB. Okay? All right? So tama si John Mediana. You don't develop anti-LEB because A is not really absent. It's just that it's not expressed as strong as the B ones. Why? Because there's so many LEB that the anti-sera will give a weak reaction. Okay, so now let's talk about the clinical significance of anti-LEA. So ano naman, sir? It's not really significant, as I mentioned earlier. They're boring. Okay, not gonna cause HTN, HTR rather, and HDFN. Why? Because for the most part, these are reactive only are at 37 degrees Celsius, and uh, if reactive, they are only significant only if they are reactive at 37 degrees Celsius. But as I mentioned before, They are of the IgM class. Okay? Meaning they are cold reacting. Okay? They're not significant. Therefore, they cannot also cross the placenta, which means that they cannot produce hemolytic disease of newborn and hemolytic disease of fetus and newborn. All right? Now, there are two variants of anti-LEB. We have the H-dependent and the H-independent variant. Ay, parang COVID lang, sir. No? What are the nomenclatures for each of the following? So yun nga. We have anti-LEA, ay anti-LEB, H, all right? For the H-dependent one or the H antigen dependent one, the terminology is LEB, anti-LEB, subscript H. Okay? Ay superscript. So meron na siyang B, meron pa siyang H. Okay? The other variant is anti-LEB L, BL. Sorry, hindi ko na complete. Alright? So these are the nomenclatures and these are the other names. Anti-LEBH, anti-LEBL. Now, what phenotypes would interact with the antibody, with the independent one, or your anti-LEBH? Who would react to these things? Well, because of the fact that they have um, they have LEBH. Remember, what is this substance made of? LEB substance made of? We'll go back to the review. It is the H antigen. H antigen is composed of what? 1,3 linkage of GalNAc and the 1,4 linkage of the 1,4 linkage of the fucose. Fucose also here. Sorry, that is basically LEB. Now, sir, parang familiar sa akin to. Parang familiar sa akin tong structure na to. Because that is basically type A. Okay? So that's a patient who is type A. Oh, wow. Oo nga. So therefore, the phenotypes that will react to this patient is either type A or because there's an H substance, what other blood type will react with this patient? What other blood type? Oh, now I want to be specific. Hindi lang H to. Ay hindi lang siya hindi lang siya A, specifically A2. Why? It will act strongly with A2 because there is less of the A antigens. Okay? Again, babalik tayo. What is the difference between A1 and A2 subgroups? Anybody in the chat? Anybody who can unmute themselves? What is the difference between A1 and A2 subgroups? Anybody? Oh, yes, correct si Ella Villamayor. Ella? Ella, where are you? Ay, nagtago. All right. Does anybody know the difference? Still remember the difference of A1 and A2 subgroups? Hello? They forgot na. Let's try Cyrene. Cyrene, are you there? Okay, so Cyrene, what is the difference between A1 and A2 subgroups? You forgot na? The inheritance of what? A1 has inherited a stronger A gene. Diba? Once you inherit a stronger A gene, so paano na naman yon, sir? Ano na naman yon? Balik tayo dun sa drawing ko ng paa ng pusa. So for example, you have the phenotype AA. Okay? You have the phenotype AA. Unfortunately, AA. So since these are just haplotypes, these are haplotypes. You only need two parts of the chromosomes, two pairs of the chromosomes, and so there's no need for another. It's not like the RH1, huh? So haplotypes. For example, you inherited the A gene here, another one here. Okay. However, that is A1. Now that is A1. Now this is A1, huh? Now A2. Gagawa akong paulit ng pusa para hindi nyo makalimutan. Paan ng pusa ang tawag ko na lang. Medyo matulis yung kuko ng pusa. Sorry. Okay. Ayan. Ayan. So this one is A2. Let's talk about A2. Now, balik tayo sa discussion natin kanina. Weak D produces a weak D status, is a weak D status because there is what? There is one normal and one is abnormal. Okay? So this one does not produce the correct or the functional enzyme. This one produces functional enzyme and therefore will produce correct enzymes. However, because of the variance between them, this phenotype or this subgroup produces more enzymes, and therefore there's more A substance in the surface of the RBCs. This one will have smaller substance in the surface of the ARBCs. Nagets nyo yung difference? Now, babalik tayo. Bakit A2 lang? Kasi, since onti yung binding sites ng A, okay? Since onti yung binding sites ng A, mas maraming H substance ang naiiwan sa surface ng RBCs. Okay? Doon kakapit si anti-LEBH. Kaya nga tinatawag siya na H independent. Okay, H independent kasi meron tayong mga sorry, dependent dapat to. Sorry, dependent dapat to. Okay? Note that LEB will react with the antibody. So I need to remove that one. Okay? Okay, so I need to remove this one. Dependent dapat siya. Sorry. Typo. Okay? So these patients need LAB to react with the antibody. Okay? Now, describe LEB reactivity. L. This time, this is the dependent one, the independent one. So this one will react to any red cell regardless of the amount of H antigen present. Sorry, hindi ko pala nabalik. Alright, so this antibody's behavior will react to the this antibody will react to the uh, directly to the BA, the LEB antigen. Okay, so it will react to the directly to the LEB antigen. It will not attach to any H substance. Okay. Now, true or false? Lewis antibodies have not been implicated in HDFN. True or false? Tandaan, true or false? Tandaan ang characteristics ng anti-LEB or Lewis antibodies in general. Lewis antigens have not been implicated. Lewis antibodies have dapat yan. Yung grammatical error na naman. Inaantok na kasi ako guys, nung tinatype ko to. So our statement is Lewis antibodies have not been implicated in HDFN. True or false? True or false? True or false? What are your answers? I want to see. True or false? Okay. What's the answer for this one, guys? Hello. I'm waiting. Ay, kaya pala hindi sumasagot yung mga tao. Kaya pala, sorry. Nag-aantay ako sa wala. All right. So, what's the answer to my question? Lewis antibodies, specifically anti-LEB, have not been implicated in HDFN. True or false? You guys can guess. We will check the correct answer later. Don't worry about it. I just want to see any I want you guys to participate in the class. So Earl said true. Okay. Germaniana said true also. Think, guys. Think about the aforementioned um, descriptions of Lewis antibodies. What are they? They are what? What's the immunoglobulin of this one? What's the immunoglobulin class of this one? And based on that one, why do you think it will not be implicated in HDFN? Diba? Oh, sabi ni Syrie, hindi ko naman tinanong kay Syrie, ang tinatanong ko lang naman true or false. Pero sabi niya, sige, IgM. Okay, so explain natin, bakit si IgM hindi siya implicated for HDFN? Oh, 'di ba? Lewis antibodies have not been implicated with HDFN. So she explained that her answer is because Lewis antibodies are predominantly HD. Okay, it cannot cross the placenta and therefore it will not be able to affect the baby. So the correct answer is true. It has not been implicated. Correct answer is true. They're predominantly IgM, and even in cases where the mother produces IgG version of Lewis antibody, the fetus is still in the transitory state. Naalala niyo yung transitory state? Wala pa si babying blood type eh. Wala pa si babying Lewis blood type. So kahit mag-produce siya in rare conditions, even if the mother produces IgG Lewis antibodies, it doesn't matter. It won't affect the baby or the baby's red cell because the baby is still inside the human is still inside in utero. If the baby is still in utero, it doesn't really matter because the blood type is a the Lewis blood type is A negative, B negative, or Lewis A negative, B negative. Gets nyo kung bakit? Gets nyo? Ang tamang answer is true dapat. Look at the question. Read the question carefully. Oh. Lewis antibodies have not been implicated. Have not. Ibig sabihin, hindi pwede. Have not been implicated. Hindi nangyari. Alright? So, sino ang tama? So, si Cyrene said true. Palmero said true. Si Earl Palmero, binawi niya. Bakit mo binawi? Tama ka na nga eh. Tama ka na nga. Si Ella Villamayor, false ang sinagot. Pero pero yung explanation niya is not congruent with her reasoning. Hoy, ano nangyari sa iyo? Ella, ano nangyari sa iyo? Sorry sir, hindi ko nabasa ng maayos. Okay?
Alright, so critical thinking skills guys ha, and reading comprehension tayo ng konti. Alright, this was actually a question in my ASCP board exam. Okay, sometimes they will ask us true or false question, true or false questions. That's the reason why I'm practicing it for you guys because I want you guys to think critically. Right? I want you guys to just not memorize what the answers are, and sometimes memorizing the answer is a good thing. Memorizing the content is a good thing, but not all the time. If you know if you know that the patient's RBC is if the IgM molecule is that one, but you don't know the function of the IgM, it doesn't really matter. Correct? Correct ba? Jan Ilagan? So kahit meron kang eidetic memory, kung hindi mo naman kayang mag-think critically, that is the problem. That's the reason why I always ask you guys true or false questions. Because I want you to think critically. Read the questions bullet per bullet, okay? Or word per word. Because unlike in the exams that you take in the school, they will not put they won't put this one. All of the following are blah blah blah, and then your professor would write except. They would put all caps on except. In the board exam, it will appear as the smaller case, lower case. So you have to be able to understand and think critically when you're answering questions for blood banking. All right. And also, guys, one tip for you guys is the reason why I'm drawing some of the things for you is because you need to have a good imagination as well. You need to know, oh, that patient has gallnut. That patient has a lot of immunoglobulin. That patient has a lot of immunoglobulins, and therefore I need to do adsorption elution. Or that patient has a lot of antibodies, but the antibodies cannot reach the antigens, and therefore I need to use enzymes. Oh, that patient has an increased production of this particular enzyme, and therefore they will produce this amount of antibodies, but they will still produce a tiny amount of that one. Therefore it follows that they will not produce the antithetical one. So please be careful, please be careful with this one. A lot of students make that mistake. Okay, so you guys need to be imaginative. You also have to have a good critical thinking skills, and you also need to have probably probably good memory. Okay, so in blood banking, memory uh, is a little bit vague. If you just want to know the facts, yes, memory would be good, but most of the time you need to imagination, di ba? Now, the traditional way of determining the Lewis phenotype of the patient is through the use of salivary demonstration or saliva neutralization test. Basically, you're going to test the patient's saliva using reagent Lewis immunoglobulins. It's either LEA or B, doesn't really matter, okay? And then what happens is you then add the patient's red cells. Okay? Now I add this one. Saliva contains what? Saliva contains the Lewis substances. What particular Lewis substance? It's either LEB. Why? If the patient inherits LE LE phenotype, the saliva will still contain LEB. Why? Because LEA locks in at the RBC and will no longer move about the patient's will stick to the patient's red cell. Whilst LEB, albeit coming from a stronger reaction from the secretory substance and the LE substance, it moves about this plasma, it moves about the red cell, okay? The plasma, the red cell, and the secretions. All right. So that one contains LEB. Now we want to test the patient's. If we want to test the patient, this one has the antigens. This one has the corresponding antibody. Okay. And if these two react together, what do you think will be the positive result? Agglutination of the patient's red cell or no agglutination? Oh, imagination ulit. Let's try your critical thinking skills this time again. If the patient is positive for LEB, so for example, LEB to, and then you have anti-LEB, what would be the positive reaction? Agglutination or non-agglutination? Ayan yung choices nyo, guys. Anybody? Non-agglutination according to John Mediana. All right. Okay. Let's see. What about other people? Serene said non-agglutination. Okay. Gina said non-agglutination. All right. What about Jovel Hitosis? Non-agglutination according to April. All right. What about Earl? Earl usually answers the questions. Earl Palmero said non-agglutination. What about John Ilagan? John Ilagan said non-agglutination po, sir. Oh, very respectful pa rin. Thank you, John Mediana, for being respectful. What about the people at the very bottom? What about Wailon Castro? And oh, I like his name. Castro and Vivian Hernandez. Sheila Sano. What are your answers? I want to hear from you guys. All right, so the correct answer is non-agglutination. Very good. Oh my God. Oh my God. Okay. Now, I'm interested to know. I'm interested to know in how you came up with the answer, Jovel Hitosis. Jovel, can you try and explain your answer? Why you said non-agglutination? I just want to see what is in your mind as to why you selected non-agglutination. Jovel? Si Jovel nagtago. Alright, balik tayo dun sa unang-unang taong sumagot. Let's talk to John Mediana. John Mediana, what's on your mind when you came up with the correct answer? What was on your mind? Huh? Why we're talking LAB, anti-LAB din yung naman yung ano, yung antibody. Hoy, magkakaroon siya ng reaction kasi ang antigen mo is LAB, LEB. Tapos ang antibody ko is anti-LEB din. Oh, lock and key mechanism, 'di ba? Magkakaroon ng reaction. Pero tama yung correct answer mo, pero mali yung reasoning. Naku, patay tayo diyan. All right, let's go to the second one. Cyrene, what were you thinking when you answered non-agglutination? I just want to see. Cyrene, are you there? All right. Let's go to Earl Palmero. Oh, sige, sure. Aha. Okay. Tapos, and then, okay. All right. Guess lang. Okay.
All right. So he's a little bit okay. John Mediana. Oo. Oh, tapos, kulang yung explanation ni Earl. Actually, tama na kayo eh. Okay. All right. Very good. Okay, so my explanation will be this. Hopefully, naintindihan nyo lahat. Tagalogin natin kasi parang nahirapan silang i-understand kapag ka-English kasi may sinasabi si Cyrene na hemolysis. Hindi ko alam kung saan niya nakuha yon. Wala naman tayong pinag-usapang hemolysis sa reactions. Cyrene ha? Ang test natin is, ang results lang natin is agglutination and no agglutination. I don't know where you got the the idea. Si Arwining, naku patay ka, lalo ka malilito dyan. Lalo ka malilito dyan. Alright. Okay. So, this one contains the antigen and antibody. They will react with each other. Okay? They will react with each other. Hence the term neutralization. Okay? When you add the patient's red cells, if the patient has the same antigens as that of if the patient's secretion is in here and the antigens are also in here, okay? They will not react. Why? Why, sir? Remember yung dinrawing ko sa inyo kanina? floats in the plasma, LEB floats in the patient's, LEB is in the RBC, okay? LEB is in the RBC, okay? So, kung na-consume na natin lahat ng immunoglobulins, sino pang magre-react sa RBCs natin? Nagets nyo? Kaya siya nineutralize. Kaya natin siya nineutralize dito. Ang nineutralize natin is this one. We're neutralizing this antibody adding tuloy, by adding the antigens here. And then by attaching this, by mixing it together and washing the suspension, leaving the flock, you will be left with a bound form of these two, LEB antigen and the anti-LEB. When you add the patient's red cell to that mix, because all of them have been reacted already, RBCs will no longer clump. Nagets nyo? Nagets mo yung idea ng neutralization? You are neutralizing the antibody. You're not neutralizing the saliva. You're not neutralizing the RBCs. You're neutralizing the the antibodies by adding the saliva. The saliva has the secretory antibodies here, okay, which is indicated here. This one will form this, and upon addition of the patient's red cells, because all of the antibodies have been consumed, or the term is neutralized, you will no longer have RBC agglutination. That's the reason why the positive result is no agglutination. Nagets? Nagets na per Earl? Okay, so ano ang nineutralize natin? Cyrene, what are we neutralizing? Cyrene, ano nineutralize natin, Cyrene? Nakalimutan na ni Cyrene. John Mediana, anong neutralize natin in the test? It's the antibodies, the reagent antibodies. Okay? Okay, so tama sana yung sagot ni John Mediana kanina. However, the reasoning is incorrect. All right? Um, Tama din sana yung binasa ni Cyrene. Kaso ibang klaseng neutralization yung binabasa niya kay Harmening. Lalo siyang nalito doon tuloy. Hemolysis tuloy ang sinagot niya. That's a different one.
you're using polyclonal antibodies, you're using polyclonal antibodies for that one. Kaya sabi ko sa inyo, kailangan ninyo mag-critical thinking. Why? Because sometimes they will not indicate whether it is polyclonal antibodies. They will not indicate this one. I made it simple for you guys. In Harmening's book, it is difficult to understand because there are some terminologies that that beginners such as yourselves will not be able to grasp immediately without me explaining it to you. This is what you call saliva neutralization complement fixation tests. Okay? This time, there are complements present in the RBCs. Has the RBC, your reagent RBCs or the patient's RBCs have been fixed with complements, and therefore, if it's not neutralized, if the cells are not neutralized, if the immunoglobulins have not been neutralized, the complements fixed on the patient's RBC will result to the hemolysis of the cells. Yun yung sinasabi mo siguro sa Irene, which is a different modification of the test. Remember, reading again, read this again. The traditional way of determining the Lewis phenotype of a patient, the traditional way. Back then, we don't have complement fixation pa. So, hopefully, Zyrene, you will not take you won't take this as a personal attack, but I hope that Harmening did not take it as a personal attack. But unfortunately, the book sometimes it's too complicated for you guys. Even if you read it, unless you have a full grasp of the content, some of the information there is just jargon. All right. Now, let's move on to the unique characteristics of the Lewis-Brill group system. Now, the Lewis phenotype of the donor's RBC will change over time to the recipient's RBC. Is this true or is this false? Kakaiba si Lewis phenotypes, guys. Okay? The Lewis phenotype of an RBC of a patient will change over time to the patient's Lewis phenotype. O, ayan, another critical thinking question na naman tayo. We're going to go back again to that particular discussion earlier. Okay, RBCs. This one is the plasma. This one is the secretion. What does it look like in the plasma, or where will the Lewis antigens attach to glycolipids? This time it's in glycoproteins. Okay, Lewis antigens are here. Okay, they float around here and sometimes attach there. Sometimes they go to the plasma. Sometimes they go to the secretions. Now, based on that particular example, how will you be able to answer this question? The clue is here again for you. It's another critical thinking question. The Lewis phenotype of a patient or your donor will change over time to the recipient's RBC. So let's talk about it this way. Um, uh-huh. Can you guys hear me? Hello? All right. So you guys can hear me, right? Now, because I mentioned the donor RBC and the recipients phenotype, we're talking about two types of RBCs. So let's use, for example, this one. LEA negative, negative. Okay? Then LEA positive, negative, positive, positive. Ay, hindi. Palitan natin yung isa kasi mas complicated yan eh. Madaliin lang natin. Ayan. Ayan. So, tatagalugin ko, sabi, yung Lewis phenotype ng donor, magbabago into this one, into the Lewis phenotype of the recipient. Is it true or is it false?
Don't lie to me. O, di ba? What do you think will be your answer? I'll explain later. I want to see everybody's answer. Try to think. I'll give you guys 30 seconds to think, and then you type in your answers in the exam, in the chat box. Okay? Ganun yung participation natin. Hindi ako magtatawag na isa-isa. Mapagod ako kakaantay. Mapagod ako kakaantay. Okay. So, 30 seconds. Please, people, answer the question. Okay? The Lewis phenotype of a donor will change over time to the patient's Lewis phenotype. True or false? Okay, timer starts now. Check later. Just want to check on some emails. Okay, so what are the answers? Ay, nobody answered. Hala, true or false na nga lang. Please, people, what are your answers? Sabayan, pati ba naman sa may chat box, mag-aantay pa din ako. Oh my God, grabe naman kayo. Galit talaga kayo sa akin today. Earl, galit ka talaga sa akin. Hindi ka sumagot. Jovel, galit, feeling ko galit kayo sa akin. True or false na lang yung choices. Kayo talaga. Oh, magbibigay ulit ako another 30 seconds. Hoy, grabe naman kayo. Zyrene, grabe ka naman. Hindi ka na sumasagot. Hirap, sir. True, guess lang. False, guess lang. Ayan na, sumagot na sila. Kasi Madaawa sila sa akin. Ang hirap magantay, guys, ha. Grabe kayo. Ang hirap. Ang hirap. False lang, pero try po. O, sige, sige, sige. Titingnan natin yung tamang sagot. Let's try, ha. Explain ko sa inyo kung bakit later. So, magbabago ba ang phenotype ni LEA negative into this one? Remember, guys, ano nga ang principle natin? Pa-transfer-transfer siya. Transfer-transfer siya. So, for example, pumasok sa system ni patient itong donors, RBC. Palitan natin yung color para cute. Gawin natin green kasi berde ang utak ko. Ayan. Becky, kunyari yung dugo na yan na pumasok na yan. Okay? So the Lewis blood group system will change, true or false. Imagine that the patient is LEA negative, B negative, LEA negative, negative. Okay? LEA negative, B negative. Once it goes inside, the cells will be exposed to what? The Lewis substance of the patient, of the recipient rather, of the recipient. Therefore, the patient's recipient, since the patient has the enzymes, all right, the enzymes to attach the fucose molecules, it will then change the patient's blood type, the donor's blood type to the same thing as that one. Okay? It will change the patient's blood type to that one. So now, what is the answer? The correct answer is true. Strangely enough, the Lewis antigens on donor's RBC will change depending on the Lewis blood type of the recipient. Diba? Kakaiba siya. This is known as the chameleon phenomenon. Chameleon phenomenon. See? See si chameleon, green siya because green yung background. Tapos to may mga orange, orange na siya. So those who answered correctly is correct. Who answered is correct. Those who answered true is actually correct. Okay? So, tama yung guess mo, Earl. Alright? Ang hirap, no? Ang hirap tandaan. Nagets nyo ba kung bakit?
Earl, nagets mo kung bakit? Ha? Ulitin ko ha. Ulitin ko para kay Earl. Papasok si, tandaan, nandoon. Papasok si donor sa sistema ni, tinagalog ko na talaga, hindi na ako nag-English ha. Papasok sa sistema ni, papasok sa sistema ni recipient yung blood ni donor. Because marami siyang LEB, kaya kasi nga meron siyang B substance, tapos meron pa siyang A substance, pero hindi na i-express dahil negative, kakapit yung enzymes na yan doon, tapos mag-a-attach ng fucose. Then para na din silang magiging ganto. Okay? Magiging na din silang parang patient red cells. And what happens is magpapalit-palitan na lang sila. Nagets nyo? Kasi ang Lewis phenotype naman actually is not really it's not really gene to protein. It's gene to enzyme to carbohydrate attachments. Okay? So nagets mo, John Medina, Mediana? Nagets mo ba, John Mediana? Alright. What about you, John Ilagan? Yung dalawang John yung gusto kong tawagin ngayon. Nagets mo, John Ilagan? Medyo. Ulitin ko ulit, John Ilagan. Okay. So baguhin natin. For example, babaguhin ko. This time naman, itong namang patient natin is negative-negative. Babaguhin natin, ha? Baguhin natin para mas masaya. Charing. Babaguhin natin. This time, magiging donor natin is um, negative-negative. Ay, positive naman siya ngayon. So, positive siya dito. Ito naman, ganito lang siya. Alright? Ganyan lang siya. Now, paano mangyayari na magiging positive to, magiging negative yung donors natin? Tandaan, tandaan, tandaan. Papasok si donor dito. Positive siya, pero magiging ganito siya. Paano nangyari yon? Naging negative yung A. Pasok siya dito, positive, di ba? Because the patient has the FUC, the foot 3 and foot 2 enzymes, mas dadami ngayon yung mas dadami ngayon yung B antigen ay yung LEB substance sa what? Sa surface ng RBCs niya. Therefore, therefore, masusupersede yung reaction or yung expression ng A antigen dito. Kaya magiging parehas na din sila. And by virtue, magta-transfer-transfer na naman sila until such time magkaroon ng equilibrium na maging kaparehas na niya yung blood type ng recipient. Nagets mo na? Jan Mediana? Ay, Jan Ilagan, sorry. Nagets mo kung paano nawawala yung A antigen, yung LEA antigen? Alright. Thank you so much. Alright. Nicole, nagets mo kung bakit true ang tamang sagot? Nicole, naloka ako kay Nicole, hindi sumagot. True daw. Alright, so that's known as the chameleon phenomenon. Alright, so now, what is a significant change? What significant change is seen in the Lewis phenotype of patients who are pregnant? Another one na naman to. Another one. We're going back to our principles, the original principles of Lewis phenotype. Ano ba nangyayari kapag ka-pregnant ang isang babae? Nagkakaroon siya ng what? Um, Naging mother na si Nicole. Nicole, what happened to you when you were you got pregnant? When you got pregnant, you had what? You had a baby bump, and then what analytes increased? Your plasma proteins, right? Kaya nga tayo nagkakaroon ng pregnancy-induced edema. Okay? Yun yung nagmamanas ka, 'di ba? Nagmanas ka nung nabuntis ka, 'di ba? So therefore, tumaas yung plasma proteins mo, correct?
Okay, so tumaas ang plasma proteins mo. So unlike dito, sa una kong discussion dito, niliitan ko lang yung maliit to, yung plasma side ng ating sample. Mas malaki siya ngayon. Why? Kasi mas madami ang space for LEB. Okay? LEB. Okay? This is above the surface of your RBC. This is your plasma proteins. Now, mas madami ang papasok kay plasma proteins kasi nga mas diluted yung sample. Okay? Or mas diluted yung nasa circulation. Yung nasa secretions, medyo onti lang din. Bakit medyo onti? Kasi nga diluted yung sample because there is an increase in plasma proteins such as albumin, globulin, and and hello? Hello? Ayan, ayan. Sorry, bumalik na wala. Buti hindi pa ako nagsalita. Okay? So, since madami yung nangyayaring ganyan, mas tumatagal yung acceptance rate or acceptance rate talaga. Since mas madami kang plasma proteins, meaning mas madami yung fluid mo, your portion of the plasma, mas nagiging matagal yung exchange nilang dalawa. Now, what do you think will be the phenotype of the patient who is pregnant? Or what do you think will be the Lewis phenotype of a patient who is pregnant? Remember, mas matagal yung exchange. Mas natetenga sila dito sa plasma protein, okay? At saka mas natetenga sa plasma protein, mas natetenga sa secretion, onti lang yung nandun sa may surface ng RBCs. Sa tingin nyo, what do you think will be the blood type or the Lewis blood group of that patient? LEA, LEA positive, LEB positive, or LEA negative, negative, B negative. Dali lang sa Irene, nagbibigay pa akong choices. L, LEA positive, V negative. Those are your only choices. Critical thinking ulit. Critical thinking. Guys, what are your answers? I will give you guys again 30 seconds to choose. Hopefully may mag-answer. If you want to guess, don't worry. I'll explain later why your answer is correct or why your answer is wrong. Don't worry about it. I will not judge you. You have 30 seconds on the clock. People start typing. Okay. Okay. All right. All right. A lot of people answered negative, 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 negative. Okay. So what else? What about other people? What about John Mediana? Did that John Mediana answer already? All right. What about Nicole? Si Nicole na nagkaroon ng edema nung nabuntis siya. What about April? What about, right? So let's see the correct answer. Okay, so LEA negative siya. That's the correct answer. Why? Nawawala yung expression. Humihina yung expression. Gets nyo? Kasi mas matagal siya sa plasma at saka sa secretion because it's becoming more diluted and it's taking the fucose to attach longer. All right? Become LEA negative. Temporary lang siya. Babalik siya after nanganak ng patient and bumalik na yung normal fluid levels. In rare cases, they would produce Lewis antibodies, but they are never really clinically significant. Yes, in rare cases, they would produce Lewis antibodies. Why? Because sometimes these patients will recognize
recognize the cells as negative. All right. Now, this is a secretory allele that is found in 10 to 40% of Asians. That is important in the Lewis blood group system. This is now known as your SEW. All right, the SEW. That's an important allele. The weak secretor allele. Okay, sorry about that. Phone is ringing. Right, this allele is present in the genotype of an individual with what possible outcomes? Okay, so these patients can have LEA and LEB substance present in their secretion, and they can express it as a rare adult LEA positive, B positive. Oh, kakaiba to, sir. Weak kasi yung secretor gene. Remember our discussion earlier, the secretor gene produces H antigens. All right. Remember our discussion earlier, the secretor gene produces H antigens, okay, and the fucose and the LE gene produces what? Produces LE attaches the chain to the type 2 molecule. The H gene is the H yeah, the H gene produces an enzyme that is much stronger than your Lewis antigen, or Lewis sorry, not Lewis antigen, Lewis enzyme, and therefore more Lewis antigens will be attaching. But in the case of weak Lewis secretor alleles, they're almost at the same level. They're almost strong. They're just as strong as as each other. So therefore, there's almost equal or relatively equal amounts of H antigen and LEA antigens present in the cells. Now, if there's equal amount of and H antigens and LE LEA antigens in the present in the red cell surface equal, there is an equal amount. It is also synonymous to an equal amount of LEB substance. I said substance. I'm not referring to it as an antigen, because as I mentioned before, they are constantly moving around the secretions or even in the plasma. So I always refer to the LEB as a substance, not as an antigen. All right? So there's going to be equal amounts of this one, and this is going to produce a rare phenotype, which is the LEA positive, B positive. And a lot of Asians are like that. So we included tayo uh, in that particular rare allele. Okay? So there's a possibility that one of us in this particular class has the weak secretor allele. And why don't we know that? Because it's not really important. Do I really need to know that? No. All you need to remember is that these types of patients will have the rare A positive, B positive adult Lewis phenotype. Okay? Why? Bakit rare sa adults to? Kasi sa children, since they have weak expression of both the S and of both the secretor and the Lewis gene, it's almost at the same level, similar to these patients. All right. Now let's talk about the disease association. Um, I think if you studied bacteriology, you will remember some of the questions. Um, Lewis antibody is what bacteria is known to be associated with the Lewis blood group system. It's the H. pylori. Okay? Why? H. pylori interacts with the LEB attached to the epithelial cells of the gastric epithelial cells rather. All right? So kumakapit din siya sa gastric epithelial cells. Yes, it attaches itself to the gastric epithelial cells. Remember that it's not just found in the RBCs, it can also be found in different cells around the human body. And unfortunately for us, this attachment to other cells in the human body, especially in the gastric epithelial cells, that's the link that that's the link that is required by your H. pylori bacterium. It causes bacterial ulcerative colitis, ulcerations, bacterial ulcer, bacterial ulcers. All right. Now, viruses or a virus that is related to the blood group system. We have the Norwalk virus. Okay, the Norwalk virus. Pathogenesis is still unknown. Okay, it's still unknown, unfortunately. And I think that's it for our discussion for the Lewis blood group system. Now we're gonna move on with the I blood group system. The I blood group system is another funny another funny blood group system. This time it's built on a different base molecule. It's built on the type 2 chain. Type 2 chain. Lewis is built on the type 1 chain and this one is in the type 2 chain. All right? So it's basically piggyback riding on the no. Imagine imagine an airplane, okay? And then that is your that's your type 2 chain. Remember type 2 chain is what? Type 2 chain is the Galnac molecule with a 1,4 galactose linkage. Okay? 1,4 galactose linkage. Right? Yun yung drawing ko ng piatos kanina. Okay? So the I antigens are actually found on top of the airplane. Okay? And what's special about the phenotypic expression is that it's age dependent. Okay, it's age dependent. What do I mean by this? Adults are phenotypically big I, while newborns are considered to be the small I. Okay? Clear? Normally. Now, what's the main difference in the biochemical structure? Adults have a much more complex carbohydrate branch. So example, this is the type 2 chain of an adult. It's much more complex kasi nga their adults are much more exposed to a lot of external it's exposed the adults are exposed to the environment much more often than newborns. And then for newborns and babies, it's basically just like this. There's probably a couple of branches, but that's the extent of it. Okay? Now, we have rare eye adult phenotype, small I phenotype, or the eye adult phenotype. It's common in Asians, again, us, and the disease associated with this is congenital cataracts. Why? Because because as we mentioned before, normally adults should have big branches in the skin in the skin tuloy in the body. But because they have the rare small eyes, um, the more they have that the more simpler the chains, the more likely the body will not be able to fend off any type of infection or any type of cataract formation. Usually, it's the body's way of defending. The more branches of carbohydrates it is on the humors, specifically the eyes. We have several humors. If you remember your anatomy and physiology, the eye has several places where there's humors, and that humor or those water-filled packets of the eye has the eyes, not the eye, eyes.
have epithelium that that normally has complex branches of this one, and thus it prevents the body from that's it prevents the formation of cataracts. These branches are helpful in formation of cataracts. But in rare cases that the patient has simple carbohydrate chains there, that's going to be a big problem. Okay. Now, congenital cataracts. Let's talk about the antibodies of eye. So eye antibodies have been associated with um, diseases or conditions that are associated with auto-anti-big eye. Please remember Mycoplasma pneumoniae and in patients who have cold agglutinin disease, auto-anti-eye, right? I think in bacteriology they always repeat this when you discuss mycoplasmas and ureaplasmas. All right, disease associated with auto-anti-small eye. Auto-anti-small eye is associated with infectious mononucleosis. So sometimes patients will form auto-anti-eye. And this is true for patients who have the kissing disease. So it's very important, especially for mothers, for new mothers, to avoid their kids to kiss strangers because sometimes I'm not saying all adults do this. All adults have EBV or Epstein-Barr virus, but the problem with auto anti-eye is that this is an auto antibody, and when it forms too much in babies, okay, in babies, it's going to cause hemolytic anemia. So please be careful. All right. So the predominant immunoglobulin class of the eye antibodies is, of course, IgM because they're cold reacting. Look, oh, cold agglutinins nga eh. Tsaka Mycoplasma pneumoniae. All right. So those are I think, the discussions that we're going to talk about with regards to eye antigens. Now, let's talk about the last one with regards to the enhanced the ABO-related antibodies, ABO-related immunoglobulins. We're going to talk about the P system. Now, the P system is there's only one official antigen in the system. It's actually the P1 antigen. All right, so the P1 antigen, hence the term P1 PK. Okay, this PK actually attaches to this one to give the patient the full phenotype of the patient, but it's never really important. Now, what are the other antigens associated to the P system aside from P1? This P1 is the original one or the only one that is in the P system. Both P without the 1 and PK are no longer part of the P system because they were discovered to be regulatory proteins in the cell surface. All right? And the function of those two is to only define the P type of the individual because P1 interacts with both PK and just P. Without these two, we cannot determine the P type of the P phenotype of the individual. Okay? Now, most population will have what type of P phenotype? Most populations will have P positive, P1 positive, PK negative. Most, or I think 100% of us will have this one in the class. It's very rare in the body. It's very rare to have a different one. So P1 is basically this. This is B1. This is basically the P1 phenotype. The genotype is this. All right. Now, in rare cases of an individual with no P antigens, what antibody is produced? Obviously, you will have an antithetical antibody. So therefore, you will produce what type of antibody? Anti-P, P1, PK. Why did I say so? Because this means that there's no antigens. Okay?
So that patient will produce this one. Now, suppose that patient is transfused with a person who has who has P antigen, so basically a P1 person, this antibody will destroy this. It has been associated with spontaneous abortions. All right. Now, the P antigen, the just P antigen, is a receptor for the parvovirus, parvovirus B19. It is the causative agent of the fifth disease, characterized by slap cheek appearance or SCA na lang kasi ang haba. And the scientific term for slap cheek appearance in the fifth disease is what you call the erythema infectiosum or or infectious erythema. All right, slap cheek appearance. Now let's talk about the P antibodies. Now, the P antibodies are of what immunoglobulin class? Just like any of the other immunoglobulins associated with the ABO blood group, it is also again IgM. Anti-P1 is seen in patients who are bird handlers or those patients who have been infected with hydatid cysts. Hydatid cysts. Okay? So hydatid cyst is caused by what? What parasite? Anybody can answer? All right. So I think favorite ninyo ang parasitology. Hindi nyo feel talagang blood bank, no? No, sa tingin ko, hindi nyo feel ang blood bank. Kasi usually pag nagtanong ako ng mga ganyang questions, nakakasagot yung ibang, pati sa kabilang class, nakakasagot sila ng ng ibang questions. Teka lang, kayo ba yung class ko sa ano? Naging class ko ba kayo sa immunology? Ella? Ah, okay, iba pala yung naging class ko sa immunology. A lot of students usually um students are able to answer a lot of parasitology questions, bacteriology questions to a certain extent, but rarely blood bank questions, no? um John Ilagan, nung nag-aaral ka nung ano before seminar, John Ilagan, are you there? Nagustuhan mo ba ang blood bank nung ano ka nung nag-aaral ka nung ano mo before seminar? Nagustuhan mo ba ang blood bank noon nung nag-aaral ka ng before seminar? Oo. Yeah, because it requires you to have imagination. So try to practice your imagination. Actually guys, when I was a student, I also didn't like this subject. And then I realized, when I took the board exam, nagulat ako. I wasn't expecting to. This is a true story. You could ask me for proof of this, but I got a 93 in my board exam here. I wasn't expecting it. I was expecting to get a high grade on hematology and microbiology because those are my favorite subjects. But I was surprised when I got the highest grade in the board exam for blood banking and immunology and serology. Then yung tips ko nga usually for my students is that you have to have imagination. You need to have a lot of imagination because you have to imagine the configuration, the antithetical the antithetical relationships between the antigens and the antibodies. And it's not just in blood banking, it's also for immunology and serology. So I think that's the reason why students think that in blood bank, when you study the blood bank course, um, it sort of becomes difficult because aside from learning to study subjects like what's the other subject? Histopathology. I think it's there in your curriculum. Usually they're together, histopathologic techniques. You have to memorize there, and then this time you have, and then on Tuesdays and Tuesdays and Thursdays, you have to study. You have to think critically. That's the time that I think it's difficult for. That's the time I believe it becomes difficult for students to think enough. And hopefully, at the end of this lecture, you guys will have a better insight on on how to approach blood banking because it's really difficult. All right, now let's move on to the hemolytic anemia associated with anti-P. This is PCH, paroxysmal cold hemoglobinuria, also known as what? Donat, Donath with H, Donath Landsteiner, Lonath-Landsteiner hemolysis. And it has two types of characteristics. It's actually known anti-P, sorry, excuse me. Anti-P is also known as what you call the biphasic biphasic immunoglobulin. All right? What do I mean by a biphasic immunoglobulin? It's it it is a it is an IgM molecule or an IgM class molecule that can react two different ways. When it's cold, it binds to the antigen at room temp na lang, RT. When it's not cold, it causes hemolysis. All right. The another term for the biphasic immunoglobulin is known as what you call the Donath-Landsteiner hemolysin. Okay. So the other term for that one is Donath-Landsteiner hemolysin. So what's the characteristics of biphasic this one? Okay. So P antigen binds when it's cold. It causes hemolysis when it's warm. Okay. Now, um, let's talk about the kid system later. Need you guys. I think you guys are having information overload. I'm gonna give you guys half a minute, half an hour to gather your thoughts. Okay, and I will be back because it's lunchtime here in my country. So for you guys, what time is it there in the Philippines? Earl. Okay. So I think it's so I think it's merienda time there in the Philippines, no? So I suppose it's merienda time. So I gotta share my clock again. Hopefully, hopefully you guys will come back. Okay, okay. So 30 minutes starts now. Okay, I'll be back. Relax, eat something, eat some sweets, probably chocolate because it's been scientifically proven to increase memory and brain brain activity. So I'll be back later. All right. Okay. Bye, Ella Villamayor. Bye, Cyrene for a while. Bye, Nicole. Bye, John Ilagan.